Hello, my name is Rich Howard, owner of Architectural Builders Supply, and this video is to bring you a closer look at the ABH number 0128. The 0128 is a classic standard entry level, the most common, almost, pretty much, center hung pivot that you're going to encounter for most door applications. When I say most door applications, because this pivot is rated for 250 pounds, it's going to be an unusual door that would be beyond that and therefore less common. The 0128 standard pivot that's available in all of the common architectural finishes, stainless steel as well, and the example I have for this video is indeed in 32D or 630 or satin finish stainless steel. And we're going to go over all the options. We're going to go over everything. Installation, specifications, my tips and tricks on how to install it, etc. First of all, let's start with a visual tour of the item from the ground up. Here's the floor portion. And that's all stainless steel. That is not all stainless steel, but that's stainless steel. Well, it might be all stainless steel. Not magnetic, or very slightly. You can see the satin finish on that. That's the floor portion. You're going to then have the arm, the bottom arm, which will be mortised, generally mortised into the bottom of the door, and that's what that's going to look like. But we're going to go over all these dimensions shortly. There's a bearing packet that's in there, and you can see the raceway of the bearings that are in there. Okay. Moving up the door, you're going to have the top portion of the pivot, the door side. And that gets mortised into the top of the door. You'll have a finished plate that will be for the header portion of the pivot. Again, this is the 630 satin finish stainless steel. I'm going to go over the available finishes as well. 32D stainless steel. Those holes, we're going to go over that in a moment as well, why they're there. Then the header portion. Called a walking beam style pivot, and what happens is when you manipulate the screw that's in here, you will drive the spindle up and down. Oh, sorry, I've got my finger in the way. So I'm pulling that spindle up, and that goes part and parcel with the installation of this item. Okay. That's the visual tour of the pieces. Now, let's talk about the specifications. This is a pivot, as I said earlier, that's rated for doors up to 250 pounds. Very common. 3070, 3080, doors in that range. Those are always going to be well below that sort of weight. This is a center hung pivot, and when it comes to pivots, there are two main types. There is center hung and offset. The reference is to the vertical axis of pivoting. Where exactly is it located? A center hung pivot means that the vertical axis of pivoting is located somewhere in the center of the thickness of the door. Somewhere in the thickness of the door, that vertical axis of pivoting will fall. An offset pivot means that the vertical axis of pivoting is measured a specific distance from the face of the door. Okay? There is a link below this video to the manufacturer's page in the product catalog, manufacturer's page where you can pull up the product catalog. From there, you'll be able to pull up the product catalog, and what we're going to do is arrive at the page whereby which we can go over the specifications of the difference between center hung and offset. The primary difference why people will ask for a center hung pivot is going to be specifically because they want the hardware concealed. They don't want to see any of the hardware. Even though you can technically see the hardware, of course, when you open the door, you're going to see part of that floor plate. You're obviously going to see the header portion. But when the doors are closed, unless you are, lying on the ground, you're not going to see the hardware. Have your head pinned to the floor in order to be able to see the hardware. Now, Now, in the current catalog, the ABH catalog, it's page I-2, I-2, where you will be able to refer to the definition of each center hung and offset. A discussion of these pivots really should start with talking about the difference between the two. Center hung pivots. Pivot point is centered in the thickness of the door. So if you've got an 1 3/4 thick door and the door is this way, it's going to be in the center of that 1 3/4 thickness. I've really never seen it offset to one side. I couldn't understand why you would want that. You would surely want it in the center of the thickness for a reason that we'll get to in a moment. Center hung pivots do not return to center, meaning they're not self-closing. People have asked in the past, I need a center hung pivot, but it needs to be self-closing. Well, that's called a center hung floor closer, is what it's called. Center hung pivots are used on double acting doors. Because of the nature of what this is, that door will, if allowed, swing in both directions. Unless, of course, you make it so that it cannot swing in both directions, meaning you would have an applied stop on the frame or an auxiliary piece of hardware that would act as a stop. Center hung pivots are installed on cased opening frames, a flat style cased opening frame. The absence of a stop will allow the door to double act. If you add a stop, the hardware will still go, but the stop would prevent it from going, and it would only go in one direction. Offset pivots, just quickly. Offset equals the dimension from the face of the door to the pivot point. Face of the door, two offsets, 3/4 inch and 1.5 inches. Measured from the face of the door to the vertical axis of pivoting. That's an offset pivot. The pivot point is 3/4 inch from the heel edge of the door. So typical pivots are 3/4 inch offset. That means 3/4 from the face of the door, but also 3/4 inch from the edge of the door as well. Offset pivots are inherently single acting alone. Center hung pivots, you can primarily conceal your hanging hardware. Offset pivots, there's no way to conceal the knuckle at the bottom and at the top of the door. Now, a significant difference to know about center hung pivots. Most people will want a center hung pivot because they want to conceal the hardware. Great, I love the idea. There is no function of an intermediate pivot when it comes to center hung pivots. Think of a 7-foot door. There are 3 hinges on most 7-foot doors. That middle hinge is there, not that it really carries a lot of the weight, but it sure helps keep the door from warping. Okay? Every wood door, not every, but almost every wood door, has an imperceptible amount of warp. Some of them have a perceptible amount of a warp, and some of them have warp that will prevent them from working. That middle hinge helps keep the door exactly in place where it is. Sure, if you have a steel door, you probably don't have much warp at all, but you do, though. You can. An exterior metal door with a dark brown gloss paint on it, southern exposure in Chicago, yeah, that's going to bake all day long, and that door will warp during the day, straighten out usually at night. The point is this: center hung pivots, you cannot use an intermediate pivot because they don't exist. Offset pivots, you can install intermediate pivots. If you have a wood door application and if you have center hung pivots, know this: any door manufacturer, all that I've encountered, will tell you that you do not have the proper method of hanging the door. Should you go to the door manufacturer and say, my doors are warped, they'll say, well, how are they hung? You'll say, center hung pivots. They'll say, there's nothing we can do for you because they're not considered properly hung. If you're going to pursue center hung pivots, be sure that the door manufacturer understands how you're hanging them and that you want to openly discuss what the warranty will be for warp in this instance. Whereas if you had an offset pivot, you could add that intermediate pivot that would give you a protection against warp without having claimed the manufacturer. It's one downside of center hung pivots. Well, actually, it's not, in my opinion, it's not the only downside. Not that there are downsides, but center hung pivots are part and parcel with dealing with the fact that you don't have any intermediate pivot concept. The other thing that you deal with when you deal with an offset pivot is the need to almost always radius the edge of the door. So if my square-ended fist represented the square end of a door, you can see that the outside portion of my door is going to bury or make contact with the jamb, unless of course I created a significant gap between the jamb and the edge of the door, like a 1/4 inch. That would be too much. Generally 1/8 of an inch is what you're looking for. What has to be done to the edge of the door to mitigate that problem is it has to be either bullnosed or radiused. If it's a single acting door with center hung pivots, you would bullnose it. Think of the top row of tile in your bathroom. That top row of tile is bullnosed. If you were to do a double bullnose, you would radius the doors, what that would mean. Let's take a look at that. I'm just sketching it out right here. Now I have a partially exaggerated drawing here. The top drawing is a bullnose. The bottom drawing is a radius. When you relieve the door like that on the outside corner, it will allow you to maintain a very tight margin between the edge of the door and the jamb and still allow the door to turn. The upside of bullnosing or radius, bullnose is single acting. Let me fill this in here. Here we go. Single acting with a bullnose would be so here's what it would look like just here, your frame. Now I'm going to draw in our pivot point. Okay, that circles the pivot point. You can hopefully get the idea that the door will rotate out, out in this direction because I've relieved the door here. Now imagine that that margin was tighter. It shows it a little bit too wide. But nonetheless, that's the concept of what you're dealing with. If that door needed to swing in both directions, you're simply going to take that door and you're going to give it the radius like that. Okay. Now, speaking from experience, radiusing a door, depending on the door construction, might cause a problem. If you have an architectural wood door, which are basically made up of plywood faces, plywood, an odd number of plies, 3 ply, 5 ply, 7 ply, 9 ply, plywood. Think of the lumber yard. You're going to buy some, CDX. It's plywood, is what it is. Door veneer is pretty much the same. It's just the difference of how many plies and what those plies are made of. So a wood door will look like that, but to show it very exaggeratingly, I will draw in the lines of the plies. Now, what will happen is, if you have a square edge door, that's no problem because those plies are so thin that you're not going to see in the edge of the veneer of the face of the door. Looking at the edge, you won't see those different lines. But when you take and you radius this, you will accentuate the width of the lines. Here's the scenario. You have maple, plain sliced select white maple. The cross banding, or the backer underneath the maple, will be of a different color for sure. It'll be made of different material. When you put your router and you bullnose that door, you radius it, you are going to noticeably see the different strata in your door construction because you've got the 1 5/8 thick core or 1.6 inch thick core, but then you've got the plywood layer on top and bottom on both faces of the door. You accentuate that when you radius it. Speaking this to someone who is a mill shop, they know all about it. They would never take a 5 or 7 or 9 ply door and radius it. They would come with no black line veneer and they would wrap the face of the door after they built the structure and put the bullnose on. So you would never see that sort of problem. Keep in mind, it's a downside, another downside, or a potential pitfall for center hung hardware. No way to mitigate warp, hardware-wise. No way to mitigate radiusing or bullnosing a multi-ply door construction. Those are two downsides, potentially. The upside is your hardware is nice and closed, you know, concealed. You don't really see it whatsoever. Now, talking about the radius, let's just talk about the radius since we're already on the subject. There is certainly a link below this video to the manufacturer's page that will show you dimensions by which to accomplish your radius. The template will usually have a note, and in all of the years that I've spent looking at pivot templates, they're frustrating at first, but after you absorb it, you'll find all the information is always there. There's never been a single piece of information not on the template that I needed to know to properly manufacture the door. Having said that, should you need help interpreting the template, feel free to reach out to us. Now, on this template specifically, heel edge of door, heel edge is going to be considered the pivot edge of the door. See note 3. Radius the heel edge of the door, 1.25" max, for 1 3/8 to 2¼ inch thick doors. So, the maximum radius that you can have is 1¼ inch, meaning think of a bullnose bit or a roundover bit. The radius of that bit cannot be any greater than 1¼ inch. It can be less, but it can't be greater than 1¼ inch, because what will happen is the radius that you put on the edge of the door will in effect not be sharp enough or aggressive enough or tight enough. If you've got a door between 1 3/8 and 2½ inch thick, if you're using a radius not greater than 1¼ inch, you're okay. So if you're doing this for the first time and you have one door to do, you have to contend with the fact that buying a roundover bit that's 2½ inch diameter is a serious investment in tooling that you may only use once. In my shop experience, when you're doing them all the time, you've got the tool. You've got the specific router set up to do just radiusing or bullnosing, or maybe you have stuff even far more sophisticated, CNC routers. If you're ordering the door from the factory, let them do the roundover or the radius or the bullnose. Absolutely. Assuming you're going to do plenty of these doors and you're going to make the investment in the tool, here's an easy way to do it. Short of having the factory make it, short of having very sophisticated tooling to do it, and you want to do it in a shop setting where you can do reasonable sorts of levels of production, and if you expect to do it over and over again relatively frequently, I would get like a 1.5 horse router, maybe something a little bit bigger. Doesn't have to be a plunge router. I would take the base of that router and I would cut it out to the point where just the screws were pretty much holding the black base onto the cast aluminum base of the router, so that I could fit this giant roundover bit into it. I would set the depth or the height of the bit such that it was right on for 1 3/4 inch doors, so that when I bullnosed one side and I flipped the door over and then bullnosed the other side, it'd make a real nice radius on the edge of the door, is how I would go about doing it. And when you have that set up and you've made the investment in the router, is probably no big deal. I don't like to have to change it over because I want the height of the router to be always constant. I don't want it to be 10 thousandths off. I don't want it to be 30 thousandths off. I want it to be consistent. So I would leave the tool set that way. And then I would just take that door, I'd get it down onto the workspace, make sure it's secure. I'd put my router at one end, on the right end, and I would run that straight down, real straight. Be very careful not to tip the router at all, because there's no way to mitigate taking too much off. Make one clean pass. Okay? Be careful when you get to the end that you're not pushing this way, because you'll round over the top or the bottom of the door. And then I would make one more pass to clean off anything, maybe a little bit of chatter, and that's it. Don't do it a third time. Then take that same door, this is your door, and you've radiused this end, flip it over and do the job again. Flip it over, should you need to. Flip it over. If you're doing a double acting door, you're going to be radiusing both the heel edge and the lock edge of the door, which could also complicate hardware, if you've got a radiused door edge. If you have any questions on how to radius a door, feel free to reach out. I'd be happy to discuss that with you. Now, we've talked about the different types of pivots, the disadvantage possibly of center hung, the advantage of the fact that it's concealed hardware. Okay. Let's move on specifically to discuss the 0128 itself. 250-pound doors, up to 3'6" by 8'6" interior doors. People have constantly and all the time said, hey, I want to hang a 500-pound door. Don't do it. I mean, it's not rated for that. Well, it's 300 pounds actually. After I had it, actually I really figured it out, and I'm going to kick the pivot point over 18 inch from the end, or put it in the center. People have done all sorts of things with pivots. I personally, regardless of where I'm locating the pivot point from the edge of the door, the template calls out very clearly that the edge of the jamb to the center line of the pivot axis is 1 5/16. From the cased opening frame, measure over that vertical axis of pivoting is 1 5/16. Maybe you're going to make that 12 inch. Okay, I understand. I personally would not exceed the weight rating of the pivot regardless of where in the width of the door I placed it. I know that people have argued that, well, 3'6" is limiting. My door is 4'6", but I'm going to kick the pivot point over 18 inch. Okay, I know people have done it countless times. I have no empirical information to tell me that it's failed, but just keep in mind that the limitations, the specifications of the door are there. Should it fail, the manufacturer is going to say we need to know more about the door. Don't install it in such a way that will allow the manufacturer to say no warranty. You have something heavier or outside of that, get it specified from ABH so that you know you're using the proper pivot hardware. They have material that is rated for far more weight than the entry-level 250-pound range for the 0128. Another very common question that I get, and I understand, I would be confused about it as well. People say, well, I need the top pivot as well. The concept is when you say 0128 or 0128, that you're specifying only the bottom pivot. And forget that. The bottom line is this: you will always get a complete set, bottom and top. The top pivot for an 0128 happens to be their 0320. And that's all of this material here. Unless you went out of your way to say, I don't want a top pivot, or you went out of your way to say, I wish to specify a different top pivot to use with the bottom pivot from an 0128, you're always going to get a set. Always, top and bottom. If you're doing offset pivots, you're not going to get a set that would include intermediate pivots. That would be specified differently. Now, talking about the 0128, let's talk about some different options that are available. And you do indeed have to select them when you are ordering the pivot hardware itself. And I'm referring to the product catalog. So here are some options. First of all, center hung pivots are very commonly used in bathrooms of hospital rooms. Pivot hardware is used with what is called rescue hardware, meaning the door will normally swing in. No problem. The rescue hardware, typically the strike, is meant so that it acts as a stop where the door will stop and not swing back out. Should the patient fall, become immobilized, and you cannot push the door in because they're literally laying in front of the door, the rescue hardware will allow you to flip the strike down and have that door swing out. So center hung pivots are used in conjunction with rescue hardware. The design of a center hung pivot is conducive to that, to accomplishing what is needed for a rescue sort of hardware. Now, more common material. Extended spindle on bottom. Standard spindle length. You can specify these up to 2 inch longer. Why would you do that? Well, you could very likely have a flooring condition where you needed a lot more spindle, okay, for the door. Or you might have a special door construction where you had a real deep inverted bottom channel for some reason and you needed a long spindle just to get this worked up into the pivot. Moving to the top pin. Extended top pins are also available. Up to 3/4 inch longer than standard. Okay, why you would want that? I happen to know that it's code in certain parts of the country that you have a longer top pin because in an earthquake, should that door, that rectangle, become a parallelogram, you want the longer spindle, the more steel into the top of the door to prevent the door, or to help prevent the door from falling out of the opening. Some people feel the door is more secure when you have a longer top spindle. I don't see that being measurable when you have a common application, and I frankly would only use a longer top spindle if I had some very unusual casework. Maybe some sort of treatment to the edge of the door. I can't think of an actual example, but where you're going to see the longer top pin is in a earthquake sort of a zone application. Security fasteners, obviously, if you're doing a timeout sort of setting, anywhere where you need to have torque screws or otherwise some sort of specialty security screw, ABH can accommodate that. And then, like I said earlier, you have to go out of your way to tell them bottom pivot only. So if you did an 0128-B, that means I want the bottom only, keep the top, I've got the top already, or whatever the case is. And those are the general options that you'll see on an 0128 center hung pivot. And for that matter, the 0127, which is in essence the same sort of pivot except that it has an angle jam, a jam angle here that you would mortise to the frame so that it would be screwed to the frame and then also sitting on the floor. You wouldn't screw it down to the floor. Why you would want that? Well, you might have some terrazzo or some sort of floor that you dread drilling into. You might have some exquisite marble floor that came from overseas and now you're going to be the guy to crack it. So maybe go with an 0127 and don't even touch the floor at all. That would be a reason for that. Now, let's talk about the template. The template basically gives dimensional properties of all the components. It tells you that the length of the top is 6 9/16, tells you the width is 7/8, gives you the dimension of how to prep the top plate into the top of the door, where to locate it, and interpreting the template. When you're doing the header, you've got that 6 9/16 length for this portion, 6 9/16. You've got the 7/8 width. You can see there that you're supposed to drill a 7/8 hole specifically at 1 5/16 from the edge of the cased opening frame over to the center line of that hole. How deep you're to mortise it for the plate, okay, and where all of that needs to lie out. Even gives you a reference on if you're doing like a steel or an aluminum frame. You can see that reference here. It's as if they're installing it onto an aluminum sort of cased opening frame. Not uncommon, but wood frames are really where mostly I see that. Shows you the dimensions on how to mortise for this. The dimensions aren't always obvious. There are times when you have to add. There are many times you have to add two dimensions together. And certainly in the case of the door portion, you've got 5 9/32 of an inch plus half of 5/8 of an inch. Okay? And that will give you the overall. How you go about mortising some of this stuff, I like to use Forstner bits because they're flat bottomed. I might take that Forstner bit, that 1 1/4 Forstner bit, and drill down and give me this portion here, and then bring my template for the rest. My template, clamp it down, and run my router through it. However you go about doing it. I'm incredibly lazy. I will seek the path of least resistance when mortising. And actually I find that to be a good idea when it comes to machining doors. The only trick, not trick, but the thing that will take some studying perhaps, is that they give a reference to what the undercut is to be from the bottom of the door. Okay? Now, when you have a finished floor undercut condition of a specific dimension, it will tell you that your total mortise from the bottom of the door is 1 inch. Okay? Now, what you're going to end up doing is deriving at how deep the mortise is going to be into the bottom of the door based on the undercut that you're achieving. Okay? So you can see there that you've got a 1 inch dimension from the floor to the top of this, and this is 1/4 inch thick. You will adjust that based on what your undercut is. From the floor to the top of this is 1 inch. Okay, how deep you mortise this is related to the undercut. If you've got a 1/2 inch undercut, you're going to be a 1/2 inch, from the bottom of the door to where this plate is. Okay. And then basically, because you're working with between 5/16 and 3/4 inch, if you had a 3/4 inch undercut and this is 1/4 inch thick, you're going to mortise this so that it's flush to the bottom of the door. Okay. All the way down to 5/16 of an inch minimum undercut, because you need to have 5/16 just for the door to clear over the bottom of the floor plate, which is called out at 1/4 inch thick. So your door would hang down to just a 1/16 of an inch over this. So 1 inch is the dimension. The depth of your preparation for the bottom arm is 1 inch minus undercut equal mortise depth. It's that simple. That's the only thing that you stare at it and you say, well, it can only be that conclusion. And they're pretty much always the same way, regardless of the pivot. If you can handle the radius, you can certainly handle the undercut prep as well. I always find, and then of course, you've got the dimension of everything. What's your vertical axis of pivoting? How far over is your mortise? And things of that nature. When interpreting the template, I always find it best to read the notes first. These are the circumstances by which, if this, then that. Okay? I don't want to have the one unusual application that is referred to on one of these notes. Notes: pivots drilled for 1/4-20 flathead machine screws or number 14 flathead wood screws. That's just simply a reference to how big the countersink are. Note number 2, reinforcing by others. If you've got a wood door, you need to very much be cognizant of the fact that you need to have wood installed, not just MDF or some sort of material that you've cut off, or particle board, or if it's a steel door and frame, you've got to be properly prepped and mortised, reinforced. Note 3 we've discussed. Radius the heel edge of the door, 1/4 inch max for 1 3/8 to 2.5 inch thick doors. If your door thickness is outside of that range, if it's below 1 3/8, you're not going to be able to fit this hardware on really. You might be able to cheat it down ever so slightly. You can go with a different radius, but if your door is thicker than that, you've got to come up with, you've got to adjust your radius. Note 4, it is the door and frame manufacturer's responsibility to check the schedule and prep the doors and frames. Sure. ABH is saying, don't talk to us if it's not prepped right. Our hardware is correct. Okay, note 5, center line of the top pivot pin must be plumb and straight with the bottom pivot. That certainly makes sense. The vertical axis of this pivot point here must be completely plumb with the vertical axis of the pivot point down here. It's crucial. You have to have it straight on. It has to be correct. Mortising the header, making sure that all your dimensions are correct, great. Drop a plumb bob down and mark the bottom floor where you're going to locate this. I generally, when looking at the template and checking all of the math for the distance from the cased opening frame to the center line, where in the center of the door it's all laid out, That's always accurate, but I like to put a plumb bob on because what you may not understand or may not be able to, you cannot visually control that, control by just where you're placing the stuff, which a plumb bob will reveal. Is the frame kicked in or out? Is there towing that's happening? And the plumb bob will reveal any sort of significant problems prior to proceeding. Looking at the other side of the template are really installation instructions. Locate the pivot, much of this we've already discussed. Measure 1 5/16 out from the door jamb on the center line of the door. That's the location of the spindle center. Round heel edge and prepare door for 1/16 minimum clearance through the entire opening. We had talked about if you don't round the door over, you're going to need like a 1/4 inch, and that's dependent on the door thickness as well, but generally a 1/4 inch. You radius that door edge or bullnose it, you'll be able to get that down to a 1/16 of an inch. Nice and tight. Exactly what it ought to be for that. You know, I'd like it to be 1/8 of an inch because we're assuming that we're doing 1/8 of an inch at the header as well. That sort of scenario. Okay, now install the bottom pivot set. Okay. The bottom pivot certainly must be level. It notes that. You're going to need to make sure your sill is level, or your pivots are level. The door will behave improperly if it's not level. It'll creep. Install the door portion of bottom pivot per the template. Mount the floor portion per the template. Okay, that's easy. Install the top pivot and pivot arm. Get everything attached is what they're saying. Get everything screwed down. Pre-drill all the holes. For goodness sakes, don't try to run these number 14 screws. And by the way, screws are included. You're going to get wood screws and machine screws for everything. You're not going to get any sort of lead anchors, plastic anchors, any way to attach that down to the floor. Go use a lead anchor if you can and a machine bolt. That will give you an installation that you'd have to practically use a stick of dynamite to blow it off the floor because those lead anchors are so good. I would not want the weight of the door resting on the reliability of plastic anchors. Let's avoid that. The conclusion of all of this is these plates are attached to the door. They're attached. This is on the floor. This is up in the header, but it's up in the header so that the pin is driven in, as I demonstrated much earlier. Take the door, set it on the bottom pivot, tip it into the opening, 90 degrees, get up and turn that walking beam to drive the pivot pin down, you're done. It's that simple. That's how you do it. Nothing else to it. There is a figure here that accentuates the fact that it must be plumb, the pivot points, and after that, there's nothing else to go over. Now, the name ABH is a name that is, I believe, about 25 years old in the world of hardware. They are a company that has continued over the years to ever so increasingly and slowly build on their core hardware of overhead stops, pivots, push and pull latches. I'm partial to ABH because they're no longer a small little company fighting for market share, but they have maintained that feeling. You can still call them up, and while their lead times are generally 1 to 2 weeks, but they're a manufacturing company. Okay, they're not wholesalers. They make things to order. Predictable, reliable, always very good quality. Customer service, excellent. Technical support, excellent. Will call and shipping department, excellent. I'm partial to them because they're a well-oiled machine. They have their act together. If you're considering a project, hospital, institution, nursing home, look at ABH. They've got great value in those continuous geared aluminum hinges. I would take a long and hard look at that product line from them before I made another decision. While everyone else has a standard duty and a heavy duty, the ABH standard is heavy duty on their standard, on their entry level continuous geared aluminum hinges. Their entry level is considered heavy duty. I take a long look at them. If you have more than an occasional need for trim and auxiliary hardware and some specialty hardware, refer to their catalog, familiarize yourself with it. You'll probably find things that you'll say, gosh, I didn't even know that existed, that sort of arrangement. If you have any questions on the ABH 0128 center hung pivot or any other ABH product, please feel free to reach out to us. Thank you.